Hi, everyone. We are going to start on targets B day 2 today, and we are going to start on page 2, where we are going to learn a new vocab word. So we are going to be at the bottom of page 2, where the rest of this should already be filled out. And yesterday we learned about compound probability, where we find two probabilities, and yesterday we learned about an or problem. It would say find the probability of this or that. And now our problems are going to say find the probability of this and that. So our keyword today is going to be and. Alrighty, so the problem will say find the probability of this happening and this happening. And just like yesterday when we had an or problem, we needed to ask ourselves a question first. For yesterday's notes, we had to ask, can these two things happen at the same time or not? For today's notes, we need to ask ourselves, are these two independent or are they dependent? And we are going to start with independent. So if two things are independent, if two events are independent from each other, these events do not affect each other. So independent events are events that do not affect each other. Affect each other. So these are events that do not affect each other. So they have nothing to do with each other. The outcomes aren't going to be reliant on what happens. So in this example, the probability of flipping a coin and getting heads and rolling a 3 on a standard dice. Well, when I flip a coin, whatever it lands on doesn't affect my ability to roll a 3 on a standard dice. They do not affect each other. Those things do not have, it's not that they don't have anything in common, which they don't in this problem, but they will not affect each other. No matter what I do with that coin, it's completely independent to a dice. So when we have an independent problem, we are going to follow this formula. The probability of A and B, remember we're going to have and, is going to be equal to the probability of A times the probability of B. So we are multiplying our probabilities now. And they're independent from each other, so I just take their two probabilities and multiply them. So in this example, what is the probability of flipping a coin and getting heads and rolling a 3 on a standard dice? I've decided that they have nothing to do with each other, so I'm going to start with my equation. The probability of getting a heads when I flip a coin and, remember that word, and rolling a 3 on a standard dice. Well, that's going to be equal to the probability of that I get heads when I flip a coin, that equals, times the probability that I get a 3 when I roll the dice. The probability that when I flip a coin and it lands on heads is equal to 1/2. The probability that when I roll a die and it turns up to be 3 is 1/6. And then I'm going to multiply those. You can either do this in your calculator or know that when we multiply fractions, we multiply across. 1 times 1 is 1, and 2 times 6 is 12. So my answer is 1/12. If you have any questions on this example, please pause it and let me know. On the contrary to independent, we're also going to have problems where there are dependent events. And I'm sure you can guess what this means, but dependent events are events that do affect each other. So these are events that do affect each other. So if we were to say the probability that two things that would affect each other is the probability that I would graduate depending on my age. Well, I can't graduate at the age of 4, so my age completely depends on when I'm going to graduate. I cannot graduate at any given age. I usually am going to graduate at a certain age. Please watch the next video for the following example.